Chapter 8, Section 5, Proving Triangles Are Similar. The side-side-side similarity theorem, just really quickly pointing out, we do have a side-side-side congruence postulate, but this is the side-side-side similarity theorem. So right now we're only talking about similar triangles. So the side-side-side similarity theorem says that if the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. So if all three sets of corresponding sides are simplified to the same ratio, then we know that the two triangles are similar. And then the side-angle-side similarity theorem, again, there is a side-angle-side congruence, but this one's talking about similarity, says that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. If you look at this example, it says, which of the following three triangles are similar? The first thing we're going to do is go ahead and compare NPO to KML. If you look at those two triangles, NPO and KML, your smallest sides, 3 and 6, would be corresponding. Your largest sides, 7 and 18, would be corresponding, and then the middle length sides would be corresponding. So in this case, it would be my 5 and 15 unit sides. We're going to go ahead and write a ratio for each set of corresponding sides. The first ratio, I'm going to go with NPO to KML, which means NPO is going to be on the top of my ratio, KML is going to be on the bottom. The first set I'm going to write is the smallest side, so I'm going to write it 3 to 6, and that could be reduced or simplified to 1 over 2. The next one I'm going to do is 7 to 18. 7 to 18 cannot be reduced or simplified. That's all it is just 7 to 18. And then the next one would be 5 to 15, which could be simplified to 1 over 3. So if you look at the three ratios that I get, I have 1 over 2, 7 over 18, and 1 over 3. Because those ratios are not the same for all three sets of corresponding sides, these two triangles, NPO and KML, are not similar. The next set of triangles that I'm going to try is QSR to KML. Again, QSR comes first, so that's going to be the ratio I put on top. KML comes second, so that's going to be the ratio, the side that I put on the bottom. The three ratios that I could write would be 10 over 6, which can be simplified to 5 over 3. I could also write 30 over 18, which could also be simplified to 5 over 3. I know that I have two ratios that are proportional, or both of those can be simplified to 5 over 3. However, I'm not ready to say that they're similar yet because I have to know the third side is also corresponding sides are proportional. So the last ratio that I can write is 25 to 15, which can be simplified to 5 over 3. Because when I wrote a ratio of corresponding sides for triangle QSR and triangle KML, and I got the same ratio for all three, which all three of those were 5 over 3, I can say that QSR, that triangle QSR, is similar to triangle KML. Now the reason why I do not have to write proportions for to show to tell whether NPO is proportional to QSR is because if they are not proportional, if they're not both proportional to KML, then they can't be proportional to each other. So I'm done with this problem. I can say that triangle QSR is similar to triangle KML because all of the ratios were proportional for those two sets of corresponding sides. This next example says in the figure AC equals 6, AD equals 10, BC equals 9, and BE equals 15. Describe how to prove that triangle ACB is similar to triangle DCE. One thing that could possibly or hopefully is that's sticking out to you is we just talked about side, 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 and side, angle, side similarity theorems. In this case, I'm only given 4 side lengths. I don't have all 6 side lengths. So side we should be thinking maybe it's out. I don't know the length of AB and I don't know the length of ED. I can find the length of DC because I know that the whole length AD is 10 and I know that AC is 6. I can say that DC is 4. And using that same idea, the segment addition postulate, because I know that the whole thing, segment BE is 15, and I know that BC is 9, I can say that EC is 6. Now, I'm not quite ready to say that they're similar yet. I can also tell that these two angles are vertical angles. Angle ECD and angle ACB are vertical angles, so I can say that they are congruent. We're probably starting to hopefully think side angle side similarity theorem. The sides, the proportion that I can set up, I can say 6 over 4. That would be AC over CD, or my shorter sides corresponding, and that can be simplified to 3 over 2. And then I can also write the proportion 9 over 6, which can also be simplified to 3 over 2. Because those two ratios have been simplified to the same ratio, I know that they are proportional. So now that I can say that by the side angle side similarity theorem, we know that the two triangles are similar. This next example says a pantograph is used to draw an enlargement of a daisy. In the diagram, PB over PD is equal to PA over PC. A asks us, why is triangle PBA similar to triangle PDC? If you notice, if you were to take those two triangles, notice that one of the side is the daisy, actually, the diameter of the daisy. So those daisies are actually going to be sides of the triangles. Notice that both of these triangles share angle P, or angle P is in an angle in both triangles. And then they also give us the information in the question. They say PB over PD equals PA over PC. What that tells us is that the two sides that are including angle P are proportional. So why is triangle PBA similar to triangle PDC? It would be because of the side angle side similarity theorem. And then B says in the diagram PA is 8 inches and AC is 8 inches. The diameter of the original daisy is 1.8 inches. What is the diameter of the daisy in the enlargement? What I've done here is I've gone ahead and set up my proportion. I've set up PA, which is 8, over the diameter of the original daisy, which is 1.8, equals the whole side PC, which it would be 8 plus 8, which is 16, over x, which would be the diameter of the enlarged daisy. When I cross multiply, I get 8x equals 28.8. You need to divide both sides by 8, and you find that x equals 3.6. The next example says, at an indoor climbing wall, a person whose eyes are 6 feet from the floor places a mirror on the floor 60 feet from the base of the wall. Then they walk backwards 5 feet before seeing the top of the wall in the center of the mirror. Use similar triangles to estimate the height of this wall. Notice that they've gone ahead and they've given us a picture that we can use, and they've actually even gone ahead and they have marked everything that we know in this picture. So what we can do is, looking at this picture, we can find the corresponding pieces. The person, which eyes are 6 feet from the ground, would be corresponding to the wall, and then the 60 feet from the mirror to the wall would be corresponding to the 5 feet between the mirror and the person. So there are several different ways that you could set up this proportion. I've set it up as 6 over 5, or the height of the person over their distance from the mirror, equals x over 60, which would be the height of the wall, over its distance from the mirror. Regardless of how you set up your proportion, and there are several different ways that you could do it, this next step should be the same for everyone. When you cross multiply, you should get 360 equals 5x. If you did not get 360 equals 5x, then something in your proportion is not set up correctly. Make sure that your corresponding pieces are in corresponding parts of the proportion. Now I need to divide both sides by 5, which tells me that the wall is 72 feet tall. The next example says use the given lengths to find the width LM of the river below. If you notice, both of these triangles are right triangles. They also are both, they have vertical angles at LMP and NMQ. We also have corresponding pieces. My side that is 8 feet would be corresponding to the side that is 42 feet. And then the side that is 5 feet would be corresponding to side LM, which would be the width of the river that we are trying to find. I can set up a proportion, and it does not, again, have to be set up this way. I said x over 5 equals 42 over 8. You could have also said x over 42 equals 5 over 8. There were several different proportions that you could have written. However you wrote your proportion, this next step when you cross multiply should be the same. So when you cross multiply, you should end up with 210 equals 8x, or 8x equals 210. Divide both sides by 8, and you get x equals 26.25, which tells us that the river is 26.25 feet wide. Today's assignment is on page 492. It's numbers 6 through 18 even, 19 through 26, number 28, and 34.